Hello and welcome to the second video in the Lasagna project where we will discuss the technology. The first item is the container beacon, which emits identification data periodically and is attached to each container that we want to track. It should be a low power device and it should also be able to function when containers are stacked on top and next to each other. The first solution would be to use a GPS receiver, but this is a high power solution, a higher cost solution, and it also needs to receive satellite signals, which when containers are stacked doesn't really work. The second solution would be painted markings, but this needs line of sight from a camera, and so for the same reason we had to go for another one. The last one is a Bluetooth beacon, which is a low power solution. It has no satellite dependency and is the solution that we ultimately decided to go with. We will use a module such as the one in the image, and if testing shows this to be necessary, we will test adding a movement sensor to reduce updates when the module isn't moving to save on power and network usage. This is a preliminary schematic, so on the left we have a battery, then a power converter, and a line to measure the battery level to detect low power situations. Then the Nucleo board is connected on the right to the motion sensor over I2C and also an interrupt pin to detect movement, and over UART to the Bluetooth module. These signals are then received by a receiver item which takes the messages, aggregates them and tags the data with location and timestamp from a GPS module, and then uploads the data over LoRaWAN. This is not a power constrained situation, but the system is stationary, so it's attached permanently to the network. It will also have some status indicators for debugging and general monitoring, such as GPS lock. The network has the first part, which is Bluetooth, where we will explore the Google Edison standard, developed specifically for Bluetooth beacons, and we will assess if it's viable in our use case. We'll also understand if error correction is needed, depending on the general interference that we get in a port. Finally, the second part of the network uses MQTT over LoRaWAN to send all the aggregated data over to the cloud. The cloud is mainly used as a storage system, as a long-term storage, and it allows for queries. These queries are for busiest locations to understand where congestion is happening, longest item routes to identify routes that are too long and should be optimized, misrouted items to find items that are where they shouldn't be, and we will also collaborate with port authorities to define more queries specific to their domain.